All right, so we're going to look today at inverse functions. You actually already know a little about inverse functions, even if you didn't use that terminology, because in geometry class, you looked at the reflection. Sorry, I didn't even put a space there. The reflection of the original across the line y equals x. So in geometry, maybe you had a triangle and let's see, we'll put that one there. You had a triangle. We're going to go ahead and put those vertices, which were -3, 2, 0, 2, and 2, 6. And when you reflected across the line y equals x, you had a rule that said that the two x and y were going to trade places. Okay? So your reflection across the line y equals x, 2, -3, the x and the y traded places, 2, 0, and 6, 2. So when we graph that, 2, -3, 2, 0, and 6, 2, we can see that that is a reflection across that line. If I folded on the line y equals x, those two triangles would rest right on top of each other. So we put this little inverse there as a way of saying this is my original function, this is my inverse function. All right, so whenever we're doing inverse functions, all we need to do is take the x and the y and they trade places. All right, so when we're given these 3 points and we're asked for the inverse, we just take each point, -3, 5 becomes 5, -3. 6, 7 becomes 7, 6. 2, -4 becomes -4, 2. All right? This is the inverse of this relation. Now we're asked, is the inverse a function? Remember when we asked ourselves, is an inverse of a function, that means does every x have only one y? The way we remember it from algebra class is we ask ourselves about the x's, because the x's can't repeat. If the x's repeat, it's not a function. So 5, 7, -4, no repeating x's, so yes, it is a function. If the x's repeat, it's not a function. If the x's are each only one time, then it is a function, yes. So let's look at the next one. 1, 3 becomes 3, 1. -5, 8 becomes 8, -5. 7, 3 becomes 3, 7. So I look only at my x's, and in this situation, I see that the x's do repeat, which means it cannot be a function. All right, so now we're going to use the graphs and the fact that the inverse is the reflection across the line y equals x as a way of showing the inverse both algebraically and graphically. So we're going to follow 3 steps. First thing we're going to do is we're going to trade the x and the y. First thing we're going to do, we're going to trade the x and the y. So x equals -3y plus 6. The next thing we're going to do is we're going to flip the equation. Okay? This isn't necessary for the work. Oh man, Miss Mendez, I can't even read what you're writing. All right. Flipping isn't necessary, but it's going to make it easier for us when we're going to solve it. So we're just going to trade sides. So 3y plus 6 equals x. And now we're going to solve for y. Solve for y. So subtract 6 from both sides. Hi, I'm making a video. Could I have a little time? Sorry. Thank you. So subtract 6 from both sides, and I have negative 3y equals x minus 6. Got rid of that 6. Divide everything by negative 3. So we've got that y equals, there's a 1 on top, positive over a negative is a negative, 1 over 3, x. Negative over negative is a positive, 6 divided by 3 is 2. This is my inverse. Remember, we put that little negative 1 to show it's the inverse. This is my inverse. We're going to graph both functions and note how it is a reflection across the line y equals x. So this line, we know how to graph a line. I begin at the y-intercept and I move using the slope. So I'm going to begin at 6 and then I'm going to move down 3 over 1, down 3 over 1. So beginning at 6, I'm going to move down 3 over 1, down 3 over 1, all the way across the graph. And that's my original function. So we're going to call it y. Okay. Now we're going to do our inverse. I begin at 2. My slope is negative 1/3. So I'm going to go down 1 over 3, down 1 over 3. Over is always to the right. We're going to begin on 2, down 1 over 3, down 1 over 3. We're going to do everything backwards to get a few more points. Up 1, backwards 3, up 1, backwards 3. This is my inverse function. So I'm going to call it y inverse. Now if I sketch the line y equals x onto my graph, you will see that my inverse and my original are a reflection across the line y equals x. Is the inverse a function? So I'm asking about this graph right here. And again, a function is when the x's don't repeat. So as I look at each x value and I look at the graph, it only hits once. It only hits once. So this is called my vertical line test, where each time it only hits that inverse function once. That means that yes, it is a function. If you're not sure what I'm saying here, just hang on, because when we get to the other side and we're looking at the square root functions and their inverse, you'll see what I'm talking about. Okay? All right, let's look at number 4. Okay? Again, we're going to follow our 3 steps to find the inverse. We're going to trade the x and the y. And then we're going to flip the equation just to make it a little easier for us to work with. Okay? And now we're going to solve for y. So I'm going to add 5 to both sides. Okay. Then to get rid of this 5/2, we could do it in 2 steps, but I think we'll go at, let's do it in 2 steps. I'm going to multiply both sides by 2. Here, I end up with 5y equals, got to distribute, 2x plus 10. That got rid of the 2. Now to get rid of the 5, I'm going to divide everything by 5. I get that y equals, leave your slope as a fraction. 10 divided by 5 is 2. And this is my inverse. Put the little negative 1 so I know it's the inverse. All right, let's go ahead and graph both of these. First, we're going to graph the original. Begin at 5, positive slope, so I'm going to move up 5, right 2, up 5, right 2. So begin at -5, move up 5 over 2, up 5 over 2, and this is my original, so I'm going to call it y. Okay, here's my inverse. It begins at 2. My slope is up 2 over 5, up 2 over 5. So I'm going to begin at 2. I'm going to go up 2 over 5. I'm going to do some backwards. Back 2, 5. Here's my inverse. And again, just like before, here's my inverse. If I drew the line y equals x, it would show that the inverse is the reflection of the original. Okay, so the y inverse again, if I check each x value, only one time does it hit the line. So that's an example that the x's do not repeat, and yes, the inverse is a function. All right, let's keep going. Alrighty. Okay, some of this is remembering how to graph. So we need to remember that this graph is a quadratic. I'm going to take the parent and move it left 5, down 1. Let's go ahead and do that. Let's go ahead and graph the original function. So I'm going to take that 0.00 and I'm going to move left 5 and down 1. And this is the graph of this function. So I'm going to call it the y. Okay? All right. Let's go ahead and do our 3-step process to find the inverse. I'm going to trade the x and the y. And then I'm going to flip it so it's a little easier for me to solve. And then I'm going to work to solve. So let's get the squared value by itself. I'm going to do that by adding 1 to both sides. I get rid of the squared by square rooting. That cancels out my square. I've got y plus 5 equals. What do I have to do when I square root in order to solve? I have to put plus or minus in the front. Subtract 5 from both sides. We've got y equals plus or minus the square root. X plus 1. I can't do this 5 inside because that's inside the radical. Minus 5 at the end. This is my inverse function. So I'm going to take that parent square root and I'm going to move it left 1, down 5. Left 1, down 5. There's my square root. That's the positive square root. Now I have to draw the negative square root. And that is my inverse function. If I draw the line y equals x, I will see that they are a reflection across that line. All right, now if you were unsure about how to tell if a graph was an inverse, is a function, this is a good opportunity to see. So let me move up a little bit. Vertical line test. If I stop right here, this vertical line hits the graph here and here. This 2 repeats. The 1 repeats. All it has to do is repeat one time and it's not a function. So this one is not a function. All right. Let's get number 6. Again, let's go ahead and graph this one first. Okay, it is a square root function, right 3, down 2. Right 3, down 2, that's the positive. Here's the negative. Now let's find the inverse. Trade the x and the y. flip them so it's a little easier for me to solve. Get that radical by itself, so I'm going to add 2 to both sides. Got plus or minus the square root of y minus 3 equals x plus 2. I get rid of a square root by squaring both sides. The parentheses are necessary and critical. Don't forget them. So what happens when you square this negative down here? It becomes positive, so I don't have to worry about that plus or minus anymore. When I square the square root, it all cancels out, and I have y minus 3 equals x plus 2 squared. All I'm trying to do is solve for y, so I'm going to add 3 to both sides, and I get that y equals x plus 2 squared plus 3, and this is my inverse function. Okay, this is a quadratic. It moves left 2 up 3. Left 2 up 3, quadratic. Again, this is clearly a reflection off the line y equals x. This is my y, this is my inverse. Vertical line test. Each x only hits the graph one time, so the inverse is a function. All right, we're almost there. Take a deep breath. I'm tired. All right, last two, we're going to ask ourselves, are these two inverses? What I think we're going to do is we're just going to pick one, find the inverse, and see if it matches. Okay, so let's pick this one. When I get my inverse, I will see if it matches. All right, so trade the x and the y. Flip the function, solve for y, so add 14 to both sides, divide everything by 2, y equals, there's a 1 on top, 1/2 x plus 7. This is the inverse for this function. Does it match? Yes. That makes yes, these two are inverses. Last one, pick whichever one you want. I'm going to pick this one, I guess. I'm going to find the inverse, so I'm going to trade the x and the y. I'm going to flip the function so it's a little clearer when I'm solving it. I'm going to square both sides. Cancels out that square root. The negative doesn't matter anymore. All I have is 4y plus 20 equals x squared. Subtract 20 from both sides. 4y equals x squared minus 20. Divide everything by 4. Y equals 1 over 4 x squared. 20 divided by 4 is 5. This is the inverse for that function. Does it match what they've given me? The question is, match. This has a plus 5, this has a minus 5, so they do not match. They are not inverses. Right. If anyone thinks that's a lot of work, there is another way to find if it's an inverse, but I'm not going to show you. I'm just going to tell you, and you can give it a try. If I composite these two functions together, the way we did in our earlier unit, either composite this into this, or this one into here, when you're done compositing the two, you will end up with the function y equals x. If they are inverses, this is what you'll end up with. If they're not inverses, you will not end up with that. That's just a challenge to whoever wants to give that a try. Composite the two functions to see if they're inverses. All right. Do your best. Have questions tomorrow. Tomorrow's a review day, so we won't have any new material, but I can take questions. Pick up a review from beside the turn-in bucket. Don't forget, if you're absent tomorrow, you are still testing on Friday, so make sure that you do the work to get yourself there. All right. Have a great night. See ya.